All right, the purpose of this video is to talk about references and how to pass references from one model to another, some different ways this can be done, and some of the pros and cons of each. So in the simplest form, let's pretend that we want to put a hole in this model and we want the information then to propagate down to the second. So if we activate our first model and grab our hole tool and just put a hole in here. And for now, let's just pretend it's say it's a 1/2 inch hole, right? We'll throw the handles out here on these faces. There we go, 1/2 inch hole. Let's give these some nice round values for now. And let's just say that the hole is through all. Okay, so we have a 1/2 inch hole all the way through on the top block. Now, if I want the bottom block to have a hole in the same location, but I don't care about size, then it's easy to reference the axis of the first hole when we create the second hole. So let's activate our green part down here, and let's create another hole. And I'm going to go ahead and pick the face that I want the hole created on. So it's going to be this face here. Same thing. Let's give it some placement. Or actually, nope, I don't need that. What I can do though now is by having the placement on this surface, if I hold down Control while the placement box is active, I can also pick at the same time this axis from the hole in the parent part. And by doing that, it makes the holes coaxial. Now their sizes aren't locked together, but the position of one hole is now related to the second. So if we go ahead and make this one through all just for fun, and let's say we make this one a little bit bigger, these two holes are now related to each other coaxially. Changing the size of the top hole doesn't impact the size of the bottom hole, but changing the position of the top hole will. So if we bring up our edit tool, sorry, I guess I have to activate this first. Let's try that again. There we go. So if we grab our edit tool here, and we make this 2 inches, right? So our top hole moves when we activate the assembly, regenerate the assembly, the bottom hole moves and they snap, right? And they line up with each other. Now, what if I wanted them to stay the same size? How would I do that? There's a couple possible approaches. Instead of using the whole feature, we could use an extrude, for example. So let's do that. Let's go ahead and just suppress, or we'll just delete this hole for now. We'll go to this hole here. I got these things backwards. Let's delete this hole, get it out of here. Okay, so this time around, instead of doing a hole feature, let's do an extrude in this bottom block. So activate, we'll do an extrude feature, and this time we'll let it cut, go through all. Placement define, we'll place it on the surface where we want to start the cutting, so right here. And we should be good for sketch setup. Now let's go ahead and reference this top hole. So if I go to sketch references, we're going to ditch these. We're just going to reference the circle itself. Okay. And now let's say I want this one to be, I don't know, let's say I wanted it to be 50 thousandths bigger than the bottom hole. Okay. Now what's going to happen is, anytime I move or change the size of the hole on the top, let me make this transparent. It'll make it easier to see. Anytime I move or change the size of the hole on the top, it will move and change the size of the hole on the bottom. So if we take, it's grabbing the wrong thing again. There we go. So we'll go to 1, and let's make it 0.75. Okay, same deal. The relationship is maintained. The bottom hole is still 50 thousandths larger, and the two lined up. Okay, so that's another approach. The disadvantage with using a reference like that is if this guy changes shape, or if I completely come in here and redefine this and the edges are different, then the references on the bottom are going to fail. Okay, that's one of the disadvantages of using actual geometry, projected edges, copied edges, anything like that, is if the number of edges change, a lot of times the thing will fail. So let me try to demonstrate that. If I go back up to this whole feature, actually that's a bad example because it has a whole feature instead of extrude. Let's do an extrude in this top block. Again, we'll remove some material, go through all. And this time, let's do something with a shape. So let's grab our palette here. Let's say I wanted to put in a, how about that one? All right, we'll snap him right there. Size looks fine. For now, I'll leave these. I wouldn't want to leave, well, here, we'll just make it strong. There we go. We don't want to leave any weak dimensions when we're done. Okay, cut through all. And same situation, let's say on the bottom block we need to have a clearance hole that's a little bit bigger than this particular shape. So if we activate the bottom block, pick on this guy, activate, do an extrude, we'll do a through all again. All right, so same situation, right? You could take and go to references, right? And you could pick this surface, and then this surface, and then this surface, and this one, and this one. And then we could come in and manually try to sketch this in ourselves, right? We could come in here and say, okay, I want to sketch a line from here to here to here to here to here, and so on. And then I'm going to have to come in and create dimensions off of every one of these, saying how far away I want it to stay. Okay, kind of a pain. Don't really want to do that. Another approach is to actually get rid of these. I don't need these either. Another approach is to use this this offset command, right? So project is going to take the actual edge that we pick on and project it directly onto our sketch plane. Offset is going to take and do some type of an offset. So let's do offset, and let's pick. Let's go ahead and pick a chain from here to here, and it says, hey, do you want to just keep this length, or do you want to flip it around and go from here all the way to here? This time around we're going to flip it, so let's say next, and we're actually going to select this entire thing and hit accept, and then it says, do I want to convert this to a loop? There are pros and cons to this. If you convert it to a loop, then it's going to try to automatically update the loop in the future if the number of line segments change or some piece of this changes. So let's go ahead and convert it to a loop. And then it says, how far do we want to offset from the references out for our geometry? So let's say we go 20 thousandths out. Okay. So now I have this sketched profile that's 20 thousandths larger than my reference all the way around. Okay. If we hit OK, we can see the cuts going through, and that's great. Okay. Now if I take and in this upper block, we go maybe make some changes. Let's say we go and put a round feature on these guys. But we do it here in the geometry instead of going into Sketcher, right? So let's do that. And then let's go down and activate our bottom block. Actually, let's just activate everything and hit regen. Okay. You can see that our bottom block doesn't have this round feature on it. Okay. So if we go down to this bottom block and we activate it, we pick on this feature and we say edit definition. Now after I go back in there and edit definition on it, now all of a sudden the loop updates and it recognizes that, hey, there's a round there that wasn't there before, and it does the update to try to keep that in the section, right? So that's one of the benefits of using the loop feature. So if I hit OK, now my rounds are included. All right, let's turn off our axes here. My rounds are included on that offset. But again, that's going to really struggle. Even the loop function is going to struggle if the shape of this changes drastically. So if we go back into our top part and we go to this, let's get rid of these rounds. And then let's get, well, that'll be fun. Let's just see if it fails. Nope, it updated. Still got sharp corners. All right, so let's go back into our top block here. Let's activate it. Let's pick on this shape and let's redefine it. And let's say now this time, instead of using the eye shape, we do something completely different. Okay, so we're going to pick on that. We're going to go to our palette. Let's grab maybe a star. Should have put that on the... Sure, something like that. Okay, let's make them a little bit bigger. All right, so completely new shape, new segments, new line segments, not related to the other loop at all. All right, this extrude's perfectly happy because I changed the sketch for it, right? But now what happens when we go to this other model, activate this lower model and try to regenerate it? Okay, it doesn't know what to do. It's failing because if I go in and I do edit definition on this, it's saying, hey, all of the references that you had before are gone. See that? All the references are gone. It has no idea how to update it. Okay, so that's one of the disadvantages of using edge references, curve references, something like that, is when the profile completely changes, the number of line segments changes, it can cause dependent sketches to fail. And so if this was a, let's say this was a progressive die, where you know, you've got a punch, you've got a stripper pad, you've got a die, you've got a riser, you've got a lower die shoe. You have to have all of these things offset from whatever our original shape is. It can become a real pain to have to update multiple blocks in a row anytime the geometry changes. So one of the things I'd like to suggest you consider is using surfaces instead of using edges or chains or loops or something like that. So let's talk about what that would look like. Let's just go into the top block here a second. And let's create a surface that represents the shape that we need to cut. Okay? So what I'm going to do is I'm going to go into this extrude here. I'm going to add a definition on it, and instead of making this a cut, we're going to make it a surface for now. All right, and we're going to make it big just so that we can see it. Matter of fact, I'm going to go both directions so that it extends well out of my model. Sorry, let's go. Let's flip you. There we go. All right, and it doesn't matter if it's capped or not. There are some benefits to capping it in terms of how we use it later. So for now, let's just go ahead and turn on capping. Let's make it big. Okay. And here's the geometry that represents what I need to cut in this particular block. Okay. What we can do then is we can take and make a copy of this surface and offset it, and then use that to cut successive layers in our stack up. So what I'm going to do is I'm going to change my drop down here to quilts. I'm going to pick this entire quilt. So quilt is a collection of all the surfaces that merge to each other. And I'm going to take and do a offset of this quilt. Actually, now that I'm looking at this, I think I want to go back and turn off the capping. I don't want them capped after all. Sorry, right here. You'll see why in a second. So I'm going to turn off the capping. I'm going to select my quilt. Let's do an offset. And let's say we need a 20 thou offset at our first level. All right, and then let's pick the quilt again, and maybe we need another offset for a die shoe or a riser, and let's say maybe that one's going to be 50 thousandths. All right. What I can do now is I can take and use these successive quilts in order to do something at the different layers. And again, there's ways to handle the reference placement for that. So initially, we need to cut out the geometry in this block. So if we pick this inner quilt here, and we say solidify, and we say cut, remove material, all right, it's going to remove the material inside the area of that quilt. So I hit OK, and you'll notice that my quilt actually disappeared as well. There's a setting that you can say consume the quilt when the cut is made. So that's one option. If you don't want to see these, we can always go to the layer tree. We can hide surfaces, and then they're gone, right? Matter of fact, you'd want to probably do that and save status so that they don't show back up in this model going forward. But for now, we need to see them. So let's turn it back on. And let's go back to the assembly. And what I'm going to do now is on this lower model, there's a couple of ways we can do this. One, I could take and just simply activate this model. Okay, I could come up here, select quilts again. All right, and with that, with the bottom model active and the quilt selected, again, I can just hit solidify, say remove material, make sure it's the right direction, and immediately I've gone and I've cut the lower block out with the shape of the quilt. Okay, so this is the simplest way to copy the geometry. I shouldn't use that word. To copy the information from the block above to the lower block. Let me get rid of this one that's failing because we don't care about him right now. Okay, so all we have is this one solidify. If I zip up above the solidify, the cut's gone. If I bring it back, the cut's there. Now, this is a very robust way of moving information from one model to the other. The only disadvantage to this approach is there are no dimensions. There's nothing here you can edit. You can't go to a drawing and say show model annotations and see dimensions from this star. So when it comes to detailing this particular block out on a drawing, someone's going to have to create dimensions, unless you're doing cut to CAD. Someone's going to have to create dimensions specifying where this is at and what its geometry is. But it's very robust because I could go back now to my first block and we could completely change the shape of this star to something else, and there's going to be no failures in the next block down. So for example, if I take my star shape here and we do edit definition, placement edit, and this time instead of using a star like that, let's say we use the pentagon. Okay, so we throw it in here, drop it there, hit OK. And as long as my offsets can physically offset from this particular shape, they won't fail. They'll still be fine, right? So my initial offsets, my initial extrude is there. The surface is used to cut away the material. My next two subsequent offsets are there. And if we go back to the lower block and simply regenerate it, we have our new shape, right? So there's a huge benefit to being able to use quilts to copy information from one model to another. Now, one of the disadvantages of directly doing a solidify is you have no way to prevent this model from changing, right? So what if I didn't want my changed shape to propagate to this model for some reason? Maybe it's already released. Maybe, I don't know, maybe you don't want it changing for some reason. You really don't have any control over that by directly solidifying. Instead, what you can do is use something called a copy geometry feature. So what we're going to do is I'm going to delete this solidify again, just to demonstrate. I'm going to go back out to my assembly. And this time what I'm going to do is I'm going to activate the lower model. I'm going to say get data. Oh, sorry, right here, copy geometry, this right here. And by default, it's selected to use something called publish geometry. For now, we're just going to uncheck that. We want to just use copy geometry feature, which is what you get when this is off. And the reference is set to assembly, meaning the position of this block relative to this block is going to control where this thing's positioned. It is possible to copy the information a different way, but for now we're going to leave that there. And then we open up our references tab, and these are the things that can be passed via a copy geometry feature. So surface sets, chains, and references. In this case, what we're going to do is we're going to say surface sets, but we want to make sure that we select quilts down here, and we're going to pick the quilt we care about, which is this one, and hit OK. And now if I go and I look at the lower block, we're going to see that there's this yellow surface there, all right, from our parent block, and it's being copied down with this copy geometry feature. The beauty of this is we have some control over the reference placement or the references that are passed. So if I do edit definition on this, you'll notice that in options here we can say how do we want to update? Do we want to automatically update anytime there's a change? Do we want to do a manual update, or do we want to do no dependency? Be careful if you pick no dependency, because it actually permanently breaks the relationship between this block and the parent. So that there is no way to get it to update again in the future. But we could set it to manual update just to show you how it works. All right, so then let's do kind of the same thing, right? Let's pick this quilt inside this model and solidify. Cut the material, and we want to keep the outside. Right, so there's our removed material. I should just note that with quilts, a copy geom feature colors the copy of the quilts, and there's ways to remove that color if we don't want it there. But if we go back now to this part here, and let's make some change to the shape. Okay, so let's pick on this here, and let's say our piece is bigger. Okay, so there's our bigger cut. If we come back out here to the green part and do a regenerate, you notice that nothing's changing, right? The size of this hasn't changed because the quilt itself hasn't changed. To get it to update, we've either got to right click on it and say update control, switch it back to automatic update, and hit regen. Now the size changed, and then if we wanted it to not update again, we could just again right click on it, update control, set it back to manual update. So that's one option. The benefit of this approach is that if I needed to do something to the quilt before I solidify it, I have the ability to do it. So let's say for whatever reason, maybe I want rounds on this. Okay, we could grab and put rounds on this piece before I solidify. By the way, just to clear that, well, I'm not going to worry about it. Okay, and now we have something that looks like that, even though the parent didn't have the rounds on it. Now, we could have also taken and done the rounds after the fact, but there are some benefits to doing things with the quilts. Okay, so that's another way to do it. It was copy geom. The third way that's a little bit even more advanced and helps with propagating references is to use something called publish geom. In a publish geom feature, you define ahead of time which references need to be present, and then when it comes time to pick them, it's a little easier to see them. So to do that, what we do is I don't even know where the command's at, so let's find it in a second. So publish geom is located over here under model intent publish geom. It looks similar to the copy geom because we're collecting the same items. So let's say that we want to collect, again, just this one quilt, maybe. Sorry, quilt surface. Yep, there we go. And we hit done, and maybe we want to name it. This is the riser cut, or maybe we should call it a riser quilt or riser surfaces or whatever, something like that. Okay, so now in the context of our assembly, when it comes time to reference that, what we can do is we can activate this model, and we can say, now this time when I say copy geom, if we leave this button checked, then it's only looking for published geom features. You notice I don't have the quilts and the surfaces and the edges. It's just saying, give me a published geom. And so if we move our mouse around, we're going to notice that the only thing that highlights is that predefined published geom. So I pick that, and I hit OK, and anything that's included in that published geom set is now in our model. That could be planes, it could be edges, it could be surfaces. Again, I think the surfaces are a good, robust way to do that. So now when I go into my green model, if we delete this one here because we don't care about it, here's the surfaces that were copied as part of that published geom feature. And again, I have the ability to just select the quilt. And frankly, if I needed, let's say the offset that was used in the assembly or in the parent part is different than what I need in this part for some reason. I mean, I still have the ability to do all the normal surfacing commands on this, right? So if I wanted maybe a little extra offset, I could do that. Right? Maybe I want to be a little bit bigger than what it really was before. Something like that. And then pick my quilt that I just created, use that one for my solidify. Move material. I guess it was right. Okay. And then all we need to do is just hide the copy geom feature that brought the surface in, or hide the all surfaces layer. Either one will work. And we have our cut here that's referencing the parent geometry but offset some additional amount. So that's a very robust way to transfer information. One thing to be aware of is copy geom features do require advanced assembly to use. If you don't have an advanced assembly license, then really the only solution is either to copy the surface manually or directly solidify. And I don't know that there's a huge difference between the two. Let me just demonstrate what that looks like. If I go back to the assembly, we could just select quilts. I'm going to pick that thing, quilt, right? Let's activate, actually let's not, let's activate the part first. So activate the part. And pick our quilt. And this time, I'm just going to hit Control C and then Control V and hit paste. And it's kind of the poor man's copy geom. So if I go back into this model, I have my quilt, but it was not copied with a copy geom feature. It's just copied, right? So I can still do things to it. I could add rounds to it, trim it, offset one side, do whatever I have to do. I can still pick the quilt when I'm done, and I can still solidify it. It's just you don't have any update control. So I can't tell it not to propagate changes that might have happened in the parent. They're going to come along whether I like it or not. Okay. So that's kind of a little crash course on references. These same concepts would extend to really any place that you need to push information from one model to another. Keep in mind that these references are parametric unless the copy geom feature has been told not to update. They're going to be fully parametric. Second, remember that any drawing that we would create from this model isn't going to have any dimensions to show here, right? So if I go to the Annotate tab, we say Show Model Annotations. There's nothing there, right? I mean, I got a dimension on this one. If I pick my block, I've got dimensions, but I've got nothing on this. So it is going to require manual dimensioning in the drawing or in the 3D space in order to get dimensions transferred. So that's kind of one of the disadvantages of the parametric nature is by referencing the parent, you don't automatically get the dimensions in the child. I think the disadvantage though is outweighed by the benefit of keeping the geometry synced up in the right space, in the right place, and then